the field of biopharmaceutical development, one of the major challenges is preparing protein samples for downstream analysis. These samples can be coming from things like biological test systems, clinical patients, serum samples, for example, or from a manufacturing process, either on the bench scale or full scale. At the other end of sample processing are the instrumentation, ranging from simple things like plate readers to more sophisticated instruments like LC mass spec. In between, in order to get protein samples ready to go on the instrument, is a scene that often looks something like this, a lot of manual sample processing. And one of the major challenges for the industry has been how to automate this type of process, and particularly how to automate protein sample processing that involves purification, quantitation, or reaction using enzymes or other chemical reactants. These have been particularly difficult to automate in the development environment. What I'm going to talk about today is a new technology called AssayMAP. It's based on a cartridge device which is centered around a 5 microliter packed bed chromatography column, a microchromatography column, if you will. And this is engineered into a cartridge device where the packed bed is supported by some insert molded filter membranes, so that any type of resin material between about 20 micron and 100 micron can be packed into this format. Above the packed bed is a conical inlet seal, and the purpose of that I'll come back to in a minute, and a sample cup with a volume of about 200 microliters. Now, there are two operating modes that the AssayMAP cartridge is designed for. The first is as a spin column. And this is different from spin columns that have been put onto the market before. First of all, the bed volume is about an order of magnitude lower than the smallest spin columns available on the market. And it's also designed to be fully quantitative in terms of binding and elution. I'll come back in a minute to how we've done that. So in this format, we're compatible with all standard microplate type liquid handling. And this can be run with simple instrumentation that one has around the lab, either in automated mode or in purely manual mode. So this is a good way to do assay development. However, the spin format does have some limitations. We can't completely control the flow rate through the packed bed, and so the media options that you can work with are somewhat limited. The second mode is a way of getting exquisite control over the flow rate, what we call our probe syringe technology. And here we have the same features of fully quantitative binding elution, compatibility with microplates. But now we've coupled the cartridge to a syringe pump so that we basically can get perfectly precise bidirectional flow control. And this allows us to run a much broader range of media and applications, but it does require special automation equipment that incorporates this probe syringe technology. Now, a little more detail about the spin format. The cartridges are mounted in a rack that is in a standard SBS microplate format. And that rack can be mounted on top of any standard SBS microplate, deep well or narrow well, 96 well plate. And any number of cartridges from 1 to 96 can be mounted in the rack. So you have complete flexibility over the number of samples. In addition to that, we've engineered a special piece of labware called a receiver plate, where the wells actually go up inside the rack, and the top of the packed bed is below the top of the receiver plate well. And the bottom of the cartridge, the outlet of the cartridge, is suspended just above the bottom of the receiver plate well. And in a second I'll show you what that's for. But this technology can be used with manual liquid handling. As you can see here, you can load in any number of samples at a time. It's also fully integratable with standard liquid handling hardware. So anything that can move plates around and pipe that into place. And here we show it being used with a robotic centrifuge and Agilent V-spin. Now, the receiver plate has two key functions. One of the major issues in getting fully quantitative binding and elution in this microchromatography format is keeping air out of the packed bed. Even a sub-microliter air bubble represents a substantial fraction of the bed volume. So air is really the enemy. And one of the ways that we deal with air in the spin format is to be able to get air bubbles out of the bed if they happen to get in there and prepare the bed for subsequent use. So we do that by filling the cup with a equilibration buffer, spinning at high speed, and then when it reaches equilibrium, when the level on the inside and the outside of the cartridge are the same, there's about 10 microliters of liquid remaining in the cup, and the bed is fully immersed. And it turns out that this process actually very reliably drives all the air bubbles out of the bed. Now the other way you can get air into the bed is by drying. The bed only has a 5 microliter volume, so it's got maybe 3 or 4 microliters total of liquid in it. And it's very easy for it to dry out and again get what is for this bed a substantial air bubble. So the receiver plate, because the bottom of the cartridge is suspended just above the bottom of the receiver plate, as soon as you have as little as 5 microliters of liquid through the cartridge, the tip of the cartridge is now immersed in liquid, and that prevents the tip from drying out, and capillary action prevents the top of the bed from drying out. So we can now spin liquid through the bed without any danger of it drying out whatsoever. Now the probe syringe technology is a little different. Here we're using a syringe instead of centrifugal force to drive liquid through the bed. And the syringe is designed with a special probe extension that gives us virtually zero dead volume, typically a microliter or less of dead volume inside the syringe. So there can be no air bubbles of any substance trapped in the syringe, and washout and carryover is virtually eliminated. And this syringe is mounted on 9mm centers in a more or less standard liquid handling head. And the cartridge connects to it by this inlet seal forming a connection with the tip of the probe that's connected to the syringe. And that inlet seal functions like a miniature lure fitting. And because it's so small, it can actually hold pressures of several hundred psi, even though only a couple of pounds of force are required to insert or remove the cartridge from the device, which is well within the range of any robotic system. So this now provides a means by moving the syringe plunger in a precise way any pipetting system is able to do. You can aspirate or dispense through the cartridge, so flow in the upward or downward direction at very precisely controlled flow rates. We can also aspirate and dispense liquid directly into the probe itself, so that allows you to load the syringe, for example, with a sample or a reagent or buffer. And it's also designed that we can affix pipette tips to the same probe syringe, so the same head can function as a standard liquid handle. This probe syringe technology is being launched commercially for the first time at the Lab Automation meeting by Agilent Technologies in their Bravo 96AM system. This is a new head that we have developed jointly with Agilent to go on to their well-known Bravo liquid handler that has 96 of these probe syringes devices in it.